Assembly of water level monitoring components required: one NodeMCU, ultrasonic sensor, voltage regulator, 9-volt battery, battery snapper, breadboard and a USB cable. First of all, we will place the ultrasonic sensor. The ultrasonic sensor has 4 pins: VCC, trigger, echo and ground. We will connect the trigger pin to the D1 pin of the NodeMCU and the echo pin to the D2 pin of the NodeMCU. Take some male to female jumper wires. Connect it to the trigger pin and connect the wire to the D1 pin of the NodeMCU. Similarly, using jumper wire, connect the echo pin to the D2 pin of the NodeMCU. Now place the voltage regulator on the breadboard. Take the battery snapper. Connect its positive to the V-in pin of the voltage regulator and the negative to the ground pin of the voltage regulator. Then take the VCC pin connect the VCC pin of the ultrasonic sensor to the VU pin of the NodeMCU. This one, VU pin. Then connect the ground to the ground pin of the NodeMCU. Then take 2 more wires, connect the Vout pin of the voltage regulator to the VIN pin of the NodeMCU. And the ground pin to the ground pin of the NodeMCU. So our assembly is done, and now we can power our NodeMCU using the battery. But if you don't want to do that, you can remove the VIN pin and the ground pin of the voltage regulator, and then use the USB cable. Connect it to the laptop or desktop, whatever you are using, and connect the other terminal to the NodeMCU to power it. Thank you.
Blynk Cloud Setup for Water Level Monitoring. First of all, open the Blynk website. Login. Then we have to create a template. We can't create more than 3 templates at a time, so there are already 3 templates, so we have to delete one of the template present. Click on the template, select edit, click on the 3 option, click on delete, type delete here, check the I fully understand option and then click on delete. Your template will get deleted. Then now we will create another new template. Click on new template, give the name as water level monitoring or anything you want. Then select the hardware as ESP8266, connection type as Wi-Fi and click on done. Now in the data stream, click on new data stream, select virtual pin, give the name as water level or anything. Then we are selecting the virtual pin as V5, data type as integer, the minimum value is 0 and the maximum value is 500. Now click on create. So the data stream is created. Now we will create an event. So whenever the water is full, a notification will be sent to us. So for that, click on add new event, give the name as water level, and this is the code we will require in our this is the event code which we will require in our code. Now give the type as warning and give the description as your water is full, and then set the limit as 1 message for every 1 minute. It depends up to you. I am giving 1 minute, you can give 5 minutes, 15 minutes, whatever is preferable. Then go to notification, enable notification, and click on push notification to device owner. Then click on create. So the event is created. Now click on the web dashboard. From the widget box, select gauge. Then click on the setting of the gauge. The title is gauge, you can give anything. Then choose the data stream as water level V5 and then click on save. So the gauge is added. So our template is done. Now click on save. Now we have to add a device. To add a device, click on new device. Since we have to delete one of the device, since we have reached a limitation, so just delete any one of the previously created device. Click on new device. Click on from template. From choose template, select water level monitoring. Then click on create. Your device is created and this is your token which we will require in our code. Thank you.
Blynk mobile configuration for water level. First of all, open the Blynk app. As you can see, the template water level monitoring is showing here. Click on the template, click on setting, click on the plus symbol and then select gauge. Now click on the gauge, select the data stream, the water level which we have created with virtual pin V5. Go back. You can see the water level gauge is displayed on the template. Thank you.
Coding for water level monitoring. First of all, open the Arduino IDE software. Here first we have defined the trigger and echo pin. We have created two variables, trigger and echo, and we have given pin D1 and D2. Since D1, the trigger pin is connected to D1 and the echo pin is connected to D2. We have written as hash define trigger D1 and hash define echo D2 to define the pins. Then we have defined Blynk print serial library to initialize for the Blynk library. Then we have included the ESP8266.h library for the NodeMCU, and then we have included the Blynk simple ESP8266.h to connect the NodeMCU with the Blynk library. Now we have created three variables, auth, SSID and pass. In the auth, we are going to paste the token of our device. To get the device, open the Blynk website. Here, if you can see, this is our device. Click here, click on device info and you can see this is the token. Copy the token and then paste it in your code. Then in the SSID, give the name of your password and give the name of your Wi-Fi, and in the pass, give the password of your Wi-Fi. Now in the void setup, we have given serial.begin and has set the baud rate to 9600. We are using serial.begin in order to display the distance in the serial monitor. Then we have given blynk.begin and inside the bracket we have given auth, SSID and pass in order to initialize our Blynk library. Then using the pin mode function, we have declared the trigger pin as output and the echo pin as input. Now in the void loop, we need to first calculate the distance using the ultrasonic sensor. For that, we have created two variables, duration and distance of long time. To initialize the transmitter of the trigger pin of the ultrasonic sensor, we need to do a procedure. For that, first we have to make the trigger pin low using the digital write function for a delay of 10 microsecond, and then make the trigger pin high using another giving another delay of 10 microsecond and then making the trigger pin low. By using this procedure, our trigger pin will initialize and start sending signals. The signal that will be received from the object, we can receive them using by the pulse in function. And when we receive this signal, the signals are high, so we need to make the echo pin high, and the calculated value will be stored in the duration. Now in order to calculate the distance, we will calculate the distance by
multiplying duration with 0.03 and dividing it by 2, and we will store this data, the calculated distance, in the distance variable. Now we are going to give a condition that if distance is equal to 2, then we will send a notification as water level or your water is full to the user. Here water level is the code of the event. To get the code, open the Blynk Blynk website. Then click on the template. Then go to events and you can see this is your event code. So copy this code and then paste it in your code here. So as soon as the distance will be greater than 2, that means the water will reach near the ultrasonic sensor, it will send a notification to us. Else, if it is not, the water is not full, then with the help of serial print function, we will display the distance in the serial monitor and give its unit as centimeter. Now we have also given blynk.virtualWrite v5, distance. This means whatever distance is measured will be stored in the v5 pin, that is the virtual pin, so that we can see the value in the gauge that we have added in the web dashboard. We have given a delay of 200 and then we have given blynk.run to run the Blynk. After doing the coding, now click on Tools, select the board as NodeMCU 1.0 ESP12E module. Here it is, and then select the required port and then click on upload. Your code will be uploaded to the NodeMCU. Thank you. Output of water level monitoring. First we will open the Blynk IoT app. Open the template. You can see the gauge is showing the level of the water. So if I put the ultrasonic sensor in front of an empty container, or when there is nothing in front of the ultrasonic sensor, its value increases. But when we put it in front of an full container, as you can see, the value decreases and a notification is sent showing your water is full. Similarly, if I want to see on our dashboard, so first we have to open our device, the water level monitoring. As you can see, the gauge is displaying the level, and as soon as I put the sensor in front of the water, the value decreases. Thank you.